We can describe the Earth as tectonically active. By that we mean that tectonic processes happen here on Earth as a result of the heat being released from our active inner core. In today's lesson, we're going to take a journey through to the centre of our Earth, and we're going to examine the structure of our planet. The crust is the outermost layer of our planet. It's the layer of the Earth that we actually live on, the outside a bit. It may surprise you to learn that the crust of our planet isn't actually one uniform rocky layer that surrounds our planet. In fact, it's actually comprised of a number of these kind of rock chunks that surround our planet. They fit together like continent-sized jigsaw pieces, and these jigsaw pieces we call the tectonic plates. And these tectonic plates come in one of two varieties. The oceanic plates are much denser and they're comprised of basaltic rocks, which gives them that extra density. And then you have the continental tectonic plates, which are comprised of granitic rocks, which makes them much less dense than their oceanic counterparts. So the crust is also the thinnest layer of the Earth, with continental crust being anywhere between 30 to 70 kilometers in thickness, whereas the oceanic crust is much, much thinner, somewhere between 5 to 12 kilometers in thickness. The mantle is the second layer of the Earth, and it's also the thickest layer of the Earth. It's a real thick boy, at about 2,900 kilometers thick. Unlike the solid crust, the mantle is composed of a semi-molten liquid rock we call magma. And due to this magma, convection currents can actually happen within the mantle. We're going to look at that in a later video. These convection currents drive the movement of the tectonic plates in the layer above. So the core of the Earth we found at the very centre of the planet, kind of like the core of an apple. Though the core in itself can be broken up into two distinct layers, both the inner and the outer core. The outer core could be described as the third layer of the Earth. It's composed of molten iron and nickel, so that means iron and nickel in a liquid state. If it weren't for this liquid state iron and nickel, we wouldn't have the magnetosphere. So the magnetosphere is a planet-wide magnetic field that protects the Earth from things like highly charged particles coming in from space and solar winds. So without it, we probably wouldn't have life on the Earth. And lastly, we have the innermost piece of our planet, the inner core. The inner core is the hottest layer of the Earth at a whopping 5,500 degrees Celsius. Though, despite these really spicy temperatures, the inner core does not melt. It remains completely solid. The reason that this takes place is because of the other layers of the planet. So the crust, the mantle, and the outer core press down on the inner core, and they put it under so much pressure that the atoms simply cannot move away from each other to become liquid. They have to stay in a solid form. And they do this even though they have exceeded the melting point for both iron and nickel. In fact, they are so hot, and they're as hot as the surface of the sun, yet they still cannot melt simply because they're put under so much pressure from the other layers, compressing the inner core so much. In theory, you could do the same thing with water, where the liquid in a cup of water could be squeezed and compressed under enough pressure where the molecules in the water simply could not exist in a liquid state, and so they get forced back into being an ice cube under that immense pressure. It's literally what's going on in the inner core at this moment in time, where the metal is just being forced into a solid state, even though it's way beyond its melting point. And so that's the structure of the Earth. And in many ways, the structure of the Earth is very similar to the hazelnut bad boy that is the Ferrero Rocher I had to that reference to, the OG videos, where both structurally are very similar. If you have a look at these two cross sections side by side, you'll notice that both of them have a number of layers, and those layers share a lot of characteristics. If you look, they both got a crust, they've both got this kind of semi-liquid middle layer, and both have a solid individual round piece in the middle of their structures. So who knows, as a little extension from this video, I guess what you could do is go home, cut open one of those hazelnut bad boys that is the Ferrero Rocher, and use it to model the layers of the Earth to help you in your revision. Who knows? Maybe you could do like a little poster with the Ferrero Rocher in the middle. I'd love to see that, in fact. So please do it. It'd be cool. Anyway, that's all from me today. So could you pack up, just like the video, subscribe to the channel, and I'll see you in the next one. Peace. And these chunks of the Earth we call tectonic plates. Wait and see. No, I want to redo that. I want to redo that. I wasn't feeling it. I wasn't vibing with it. You've got to vibe with it when it comes to when it comes to geography. You've got to vibe with it. You've got to vibe with the geography. We can describe the Earth as tectonically active. By that we mean that there's tectonic processes which happen here on Earth as a result of our active inner core, which releases heat and drives. No, I'm waffling. Unlike the solid crust, the mantle is actually composed. Composed is not a word. Unlike the crust, the mantle is composed of. Okay. Unlike the crust, no. So it may surprise you to learn that the crust of our nope. I'm going to do that one more time. I'm not vibing with it. It's got to be about the vibe. Must get the vibe right.